Ruth é desenvolvedora web e uma tecnóloga criativa com mais de 10 anos de experiências em sites e aplicações web. Prestativa, gosta de instigar as pessoas para que tenham acesso a novas tecnologias, mostrando formas interessantes de usá-las. Suas atividades favoritas incluem hackear hardware e levar códigos de áudio e vídeo para as ruas, ou mais recentemente, em conferências. Ela também sabe o nome de todos os personagens do Thundercats.
Hello. Hello, Brazil. My name's Ruth. You can find me all over the internet as @Rumira. That's Twitter, GitHub, Copen, whatever your flavor. There's a whole theory on the speaker circuit about how you follow Jake Archibald doing a talk like that. That was an incredible talk. And I don't have a Game of Thrones opening, right? So this is the second time this year I've had to follow him as well. So rule number 1, start with Game of Thrones. Well, I don't have that. Rule number 2, don't talk about web. There is going to be web, don't worry, that's a little bit of a lie. I'm going to talk to you all about MIDI, which seems like a very strange topic, but bear with me. Now, there is a reason I want to talk to you about MIDI. That's because there's a common misconception about MIDI, and it goes a little something like this. Right? I'm sure we've heard this. That's a real website, by the way. That's a modern website. That's CameronsWorld.net. I recommend you all look it up. It's amazing. That music that you heard, that's not MIDI. That's digital audio, right? Those bleepy noises, whenever you say the word MIDI, people think of those bleepy noises. There's a good reason for that. That's because MIDI stands for Musical Instrument Digital Interface, right? So people sort of get hung up on this musical instrument bit, and I will touch on musical instruments a bit later, so you'll understand why. But the real interesting thing about MIDI is digital interface, and that's what I want to talk to you about today. MIDI came around after a rise in sort of popularity of digital instruments in the 70s. And so they had a bunch of industry experts come together, so people who are building musical instruments, musicians, everybody like that sort of came together in the early 80s. And they thought to themselves, wouldn't it be nice if all these instruments had a protocol so they could talk to each other, like, all the same, right? So in 1983, they created MIDI specification. And at the time, it was General MIDI 1. Now, there's loads of MIDI specifications today, and I'm going to take you through some of them. But if we start with General MIDI 1, General MIDI 1 was made of 3 main parts. There was the actual digital specification, and this was messages that were sent back and forth from all these sort of digital instruments that they had. There was a file format. Now, this doesn't really stand as a file format so much today. This is usually part of other file formats. And I'm not going to talk to you about it. If you want to find out more about it, I'm sure you can find out more about it on the internet. And there was a connector specification. Now, I'm sure you've all seen it. This is a sort of fat DIN connector with sort of 5 pins in it. And you usually used to find it on the back of sound cards, and you can find it on all the digital instruments. This has sort of been superseded by USB, and I will touch on it a bit later. But that was General MIDI 1. Today, like I said, we've got lots and lots of specifications. You can find out loads more about them, and they're all written down on MIDI.org. They've just refreshed the website, and you can just go and have a look at all of them. It's quite interesting. They do have a lot. The crux of all the specifications, like I said, is this messages. So with General MIDI 1, there's 2 main parts of messages. There's channel messages and there's system messages. So if we take something like a digital keyboard, and I'm not talking about the keyboard on your laptop, I'm talking about a musical keyboard. Channel messages are sort of the messages when you press a key and you make a noise, right? So channel messages are, I'm this key and I'm being pressed this hard. System messages are, I'm a digital keyboard and I want to talk to this other system over here. I would like to demonstrate this by showing you. I'm hoping that you all have devices. This is an interactive presentation, which is going to be a bit crazy later because there's a lot of you. So if you go to this URL on your device, I can see some people have got this out. I will spell it out for you in case some people can't see it. It's goo.gl/9y7, capital K, DB. I did get that right. And if you click on the green link that you see, you should be presented with a musical keyboard. Can I get like a nod if somebody's got that? So, yes, woo! And if you press on the keys, you should be able to see some MIDI data, right? Should be something a little bit like this. It's a little bit more fancy, the one that you've got, to the one that I've got. And please don't click on any of the other links, because otherwise I'm going to have to mute this. Thanks. We're doing that later. Don't do it now. Please. There's so many of you. It's going to be crazy. What you're seeing there, that data, that's exactly what you get if you instigate the Web MIDI API. So if you plug in a musical keyboard into your computer and you run this code, that's what you get back. It's that simple. It's that low level. That's the bulk of the Web MIDI API, right? All you're doing is requesting MIDI access on the navigator object. It's going, hello, yes, I've got a MIDI instrument. You've got on MIDI success, on MIDI failure, and on MIDI success, all we're doing is just looping through the inputs for that musical digital instrument, right? Simple. There's a few other features, like you can see what other MIDI instruments that you have on your computer. There's a sysx false flag, which you can see in the code there. If you set that to true, that means you can send data back to the instrument as well as like pulling it into your computer. But for the bulk of it, that's the Web MIDI API. And actually, that's pretty powerful stuff. We've got some hardware and we've got some data from that hardware. Now, this data is quite interesting, but what is it? We've got 3 numbers, right? The first number is note on, so when we press down, this is note on, and there's some sort of channel information about it as well. The second number is what note you're playing. If you know anything about music, 60 is hex for C, so that's like middle C on a piano. And then 100, the last number is the velocity, so how hard you're pressing it. And that's a number between 0 and 127. So the harder you press, the higher the number. There's also a note off, which you don't have on your demo, but it was on mine. So when you release, it also sends a message as well. And it's the same thing. You've got 3 numbers. Support's not too great at the moment. It's supported, no flags, you don't need any flags. It's supported as is in Chrome and Opera. I think the more we use it, the more support we'll get for it. But it's fine. I mean, you can still just plug in and play with any sort of MIDI-enabled instrument. Now, this data is really interesting, right? I don't know whether you've seen this talk by Jake Archibald. It's pretty cool. He talks loads about sort of progressive web apps and service work and all this stuff. I actually saw it back in London. It was good. I took away one thing from this talk. Poo emoji, right? But it was really interesting because he was doing this thing with streams, which you all saw, where he took 3 numbers. And okay, you need 4 numbers for emoji. But I was thinking, MIDI, it's 3 numbers. Yeah, we can make that into 4 numbers. I mean, we've got code. We could just run it through a parser. We can make it into 4 numbers. I'm wondering if you could play emoji. Funny enough, you can actually play emoji. If you go back to the home page and click on the yellow link, you'll get another keyboard. And when you press the keys on that keyboard, you get emoji. It's not a perfect science, by the way. Sometimes you don't get emoji, sometimes you get a little square. But for the most part, the keyboard can play emoji. See, this is what MIDI is. It's not all about sound. It is just about data, and you can do some amazing things with this data. I'm kind of hoping all of you are playing emoji. I love that demo. But what about sound, right? At the end of the day, this is a musical instrument digital interface. So for the most part, we are going to want to use sound with it. And so on the web, we have the Web Audio API. So this is sort of MIDI's companion. So you'd take the MIDI data, and then you'd sort of marry it with the Web Audio API, and that's what you would use to make the sounds for the musical instrument. Now, there's an audio sort of talk coming up later, so I'm not going to go into too much depth with the Web Audio API, but there's 4 main ways to make sound with the Web Audio API. You can actually create an oscillator with it, so that's just creating a sound wave within the API itself. You can grab audio and video from the DOM, so you can grab it from the audio and video like elements, and you can like grab the audio from that. You can stream it from a source, so that's like your microphone or your camera. You can stream the audio from that and pipe it into the audio API. Or you can grab it from a file, load it into a buffer, and then just play it out. This is one of my MIDI controllers. I'm oscillating some sounds with the Web Audio API, and that means when I press on the MIDI controller, we can play some sounds. What? Oh. Okay, so we have other features with the Web Audio API as well. Right there, you saw some distortion. And it's just simple. You're just marrying the code from the Web Audio API with the data that you're getting from that MIDI controller. Recording is important in MIDI. There's a MIDI machine control specification, and it's important because we're playing music. We want to record it. And there's lots of recording desks, all MIDI enabled, so there's a MIDI machine control specification. This is so that recording systems can communicate with MIDI instruments, and they're all using the same data protocol. On the web, we now have a media recorder API. Right? We can marry web specifications with MIDI specifications. It's quite interesting. I don't have a demo for this, which is interesting, but it's again very simple. We just instigate new media recorder and then pipe in a stream. So you can take things like your microphone and your camera, and you can record those and then use them on your web application, your website. This is actually landed in Chrome and Firefox back a few months ago. If you want to see some cool demos about it, Soledad from Mozilla has written some really, really good demos on the Mozilla Hacks blog, and I recommend you that you read it. It's very, very cool. We talk a lot about MIDI instruments, and I'm sure that there are some of you in the audience that actually know a lot about MIDI-enabled instruments and controllers and synthesizers and know all about the difference. I'm sure there are some of you that don't know anything. So let me take you through just a few of them. This is a musical keyboard. This is probably one of the most common MIDI-enabled instruments. You've probably played on one, you've probably seen one. It's actually cheaper to get one that's MIDI-enabled than it is to get one not MIDI-enabled, because it's so easy to get MIDI-enabled stuff these days. They usually run on USB rather than the DIN connectors if you buy a new one. This is a digital drum kit. It has onboard audio, so you can just set it up and you can just start playing the drums, and it plays drum sounds. It makes it more expensive to have onboard audio, but it also produces MIDI data. So you can kind of plug one of these into your computer as well and actually get the MIDI data, which could be quite fun. This is a launch pad. I'm sure you've probably seen or heard of these. This is more along the lines of what we'd see as a developer. This is a MIDI controller. This doesn't have any onboard audio, so this is actually relatively affordable. It runs in about $70 USD. I don't know the conversion, I'm afraid. So this is basically just an array of buttons. So you can plug this in and you can use it with sound and you can make sort of sequences and things with it, but you could just use it as a piece of hardware to control things. There's a whole range of different MIDI controllers out there. There's things like these ones, and you saw the video of this one. The top one's an API. I've got this. It's just 8 pads and 8 dials. And again, it's just sending MIDI data to your computer. This runs at about 40 USD, so that's even cheaper. So if you want something just to buy and play with and just play with the MIDI API, I recommend one of these two. The bottom one is a Korg Nano pad. It's got 16 drum pads. They're velocity sensitive, so the harder you hit them, that you get different values, that's great fun. On the left there, it's got a sort of mouse sort of trackpad thing as well, so you can also play with that. That sends very interesting data. And just to show you the different range of controllers that you can get, this is an Icon iDJ. Again, there's no onboard audio on it. The idea is that you pipe different tracks to either side, and then you can sort of mix them and DJ with them. I use this in a different way. I use this to mix my visuals. So I don't use this with any sound again. I just pipe different sort of videos to either side, and then I use the crossfader to mix in between, and then all the dials with different effects. It's just sending me data, and I can just manipulate that data with code. It's affordable hardware. And the web is very much hardware ready, especially with JavaScript. I mean, we've got things like Tessels, Esprinos, things like controller boards that we can code with hardware. But if you want to add things like dials or sliders, there's a lot of soldering. There's quite a bit of onboarding, which can be fun. But if you just want to plug in and go, this could be the answer for you. This is a synthesizer. Synthesizers are beasts unto themselves, and they're quite hard to sort of get your head around if you haven't got a lot of them or you haven't seen them. Like, they have onboard audio, they might not, you might want to put audio on them, you can record, you can change, there's filters, they've got step sequencers. I thought it would be a really good idea if we kind of built our own step sequencer, so you had an idea of what a step sequencer does. This may or may not work, because there's a lot of you. It's already playing. Yeah, this is how many of you there are. Wow. So each one of you has a track on my step sequencer. That's all of you on my step sequencer. And when you light up the different, the color of the link for this, is blue. So if you go back to the home page and you click on the blue link, you will get your own track on this step sequencer. I think it's overloaded. And so when you click on that, when you light up, you will make noise on this. Yeah, it's it's supposed to take about 30 people. I wasn't expecting 1,500 of you. I apologize. Wow. Maybe we can get that up and running later outside with just a few less. Yeah, it can't cope with playing all those noises at once. But yeah, normally you'd have a different track for like a different row for each of your tracks of audio. And then you press the lights, and where those lights are on, that's when the track plays. And that's a step sequencer, and another type of instrument, right? Oh, great. I'm just going to mute that. It usually makes a lot more noise than that. Timing is really important, and it's very, very hard on the web. The way that I got the timing to work on that, and the audio wasn't great, so you couldn't really hear it, is I was using a library called Tone.js, which I highly recommend. It's just a layer on top of the audio API, and it deals with things like getting timing and sync and things like that. There's a MIDI clock, which is an overriding clock in MIDI. There is no timing within the Web MIDI API itself, probably because there's this draft sitting in the W3C. If you don't take anything else away from this talk because you have no interest in MIDI or audio, go and read this draft. It's really, really interesting. This is about an overriding timing object in your app or website, right? A few quotes. It provides a unifying API for timed operation or temporal control, which is really, really interesting. This isn't just about sort of audio or MIDI timing. This is about animation timing. It's about any of the other media elements we have. This is about sort of synchronization if you're doing any kind of real time over things like WebSockets, WebRTC, anything like that. This will provide you with a unified timing for it, which is very, very powerful. I mean, we don't have great timing in JavaScript right now. This looks to solve it. How they implement it, I don't know. And that's probably why it's been sitting in draft for quite a while. We're probably trying to figure it out. But it will hopefully solve a lot of these problems, especially with the Web Audio API. There's not great timing in that either. Connectors. So we've got this hardware. We've got USB, right? That's the main connector these days. We've sort of done away with the 5-pin DIN cable. It's big, it's expensive. USB's cheaper and easier, and we can run data back and forth rather than plugging in and out, which is what we used to do with DIN. We've also got Bluetooth. There's a Bluetooth MIDI low energy spec, and this is encoding and decoding MIDI over Bluetooth low energy. It's relatively new. This is a Bluetooth MIDI controller. This is my new one. This is my handbag MIDI controller. I really like it. I'll switch it on for you, because hopefully it'll work in this darkness. Yeah, there you go. So it's just, again, it's quite nice, just some buttons. I've got a little slider up here. Hopefully, if we can set, this isn't my laptop, if we can set my laptop up tomorrow night, we'll be able to play with this. Fingers crossed. I'll be doing some visuals, and this is what I use to control it. This works over the Web MIDI API, because currently we do actually have a Web Bluetooth API, but we don't have any GATT services for MIDI. Now, the Bluetooth API is under a flag in Chrome. And you, again, just request Bluetooth request device from the navigator object. It's a good API to go and play with if you're into your hardware, but it can be a little bit flaky. You kind of need new Bluetooth chips and stuff, but there's a lot of work going into it, and it's going to be big. It's all about having a sort of Bluetooth low energy device, so something like a fitness watch, and being able to read sort of data from that back and forth within your browser, which is amazing. There's a lot more information about it on developers.google.com/web if you want to read about it. So we talked a lot about sound, and we talked a lot about hardware, and that's sort of the crux of MIDI. But we can go beyond that because we do have this data. there's a MIDI Show Control spec. So this came around sort of pretty soon after the MIDI General MIDI spec. And this was because they had a lot of MIDI data on stage. I mean, these musicians were using MIDI-enabled instruments. And so the lighting people and the pyrotechnics people were like, this looks like a good protocol. We can use this to control lights and pyrotechnics. So they came out with a show control spec. They actually used it for other things. So the big fountains outside the Las Vegas casinos, still controlled by MIDI because they still use this specification. Some of the lighting spec has been superseded by something like DMX, but it's still a specification that's hugely influenced by MIDI. There's a MIDI visual control spec. This is one of my favorites. This takes MIDI data and actually uses it to control visuals. So nowadays, when you go and see a band or a DJ or something like that, or a show, you don't just watch them. There's a whole visual show going on behind them. So the people doing these visuals are like, well, we've got all these instruments producing this data. Why don't we do that to control the visuals as well? So let's do that as well, shall we? I don't know if this is going to work. If you click on the white link, hopefully you'll connect to me with any luck. This only works over Wi-Fi. Is there anybody connecting? Maybe if I refresh. No? I'm going to refresh. You're going to have to connect again. I think my Wi-Fi's gone. Oh, wow. Oh, whoa. Okay. Whoa. Crazy. Maybe we overloaded that as well. Okay. Oh, yeah, there's just too many people. So, I can't play the audio. So the idea was that you should be able to analyze the audio with the audio API, much like you would with the MIDI data, and then, yeah, see, there you go. JavaScript! Woo! Oh, that would have been so good. Thanks. We can run it up again if you want to. Do you want to? Okay. Thank you. Oh, snap. Yeah, snap, thanks. Okay, so if we all click on the white link, yay! Thank you, people. Okay, so we're analyzing the audio. And that's going to make all these JavaScript logos flash and not die. Oh! Yeah. Oh, I really need to test these better. It's really hard to test it with 1,000 people, though, isn't it, right? Okay, thanks. Thanks. Okay. Anyway, that's really cool. Thanks for connecting to my visual demo, people. Thank you. I appreciate it. So yeah, you all connect. I analyze the audio. Everything flashes. It looks really amazing. Demo done. Yay. Nothing breaks. Oh, dear. Oh, that one's cool. That one's still going. So we can mimic quite a lot of the MIDI specifications with what we have on the web now, which is kind of amazing. But I kind of know what you're thinking. You're thinking, well, yeah, this is great, Ruth. I mean, all these fun demos that totally work, and all this hardware. Like, I kind of sit and make websites and web apps. Like, I'm probably not going to use this. People have. There's a company called We Make Awesome that actually took an artist and made like a sequencer. Oh, that's weird. That's gone really loud. Made a sequencer on the web. They emulated one. And if you had a launchpad, you could plug it in and use the launchpad with the website. If you didn't, it would still work because it was emulated on the website. They had 30,000 launchpads plugged into this website. That's not a number to be sniffed at. Even if people were doing it multiple times, that's quite a lot of launchpads out there. People were really sort of interested in this stuff. There's other uses as well. We talk about navigating web pages with mice and like your laptop's keyboard, but it's still kind of fiddly and the buttons are still quite small. I mean, these controllers, the buttons are bigger and you've got sliders and dials. I mean, you could think about accessibility uses for this stuff. Dinosaurs. Yeah. We have a theme park in the UK that has these huge dinosaurs on it, and they have huge metal skeletons inside, which run off Raspberry Pis. Now, we all know that we can run Node off Raspberry Pis, so one of my friends actually hacks these dinosaurs and makes them move around with JavaScript. And he was thinking of ways to make them more interactive. So you can walk around the theme park, and then when you walk past the big T-Rex, it can move, like you can put a motion sensor on it, and it can move to look at you, to scare you as you walk past. So he was thinking, yeah, we could get some MIDI controllers. So you could come up and you could actually move the smaller dinosaurs yourself. That's a great use for it. Control your home. Like, all our homes are hooked up to everything right now with the Internet of Things. So your homes are running off JavaScript. This is a desktop drum machine. So this doesn't have any onboard audio. This is just sort of a set of buttons. You could hook one of these up to your wall and control your lights with it. You can have wall disco lights just running off MIDI. You could create yourself a VJ pack, right? So you can take a MIDI controller, you can write yourself some software which mixes visuals, you can play some music, you can hook it all up like as an usherette tray, which is what I did last Christmas. And I took it to the streets of my city and I walked around projecting onto walls, which is super good fun. I recommend doing this. I wrote about it on 24ways.org if you want to read more about it. I was talking about MIDI, but MIDI has a lot of specifications, like we do on the web. And they're still bringing out specifications. It's a really, really great industry. They're open about it, and they talk about it, and they think, what's new and upcoming? What sort of specifications, like what do people need? What does our industry need? And we do the same on the web, and I think that's really, really important. And we've got new and exciting stuff coming out right now, and it's great just to use it and to try it and to feed back into the industry. We might be bringing out stuff that you don't need, and we want to hear about that as well. So I wasn't just talking about MIDI. Thank you very much for listening. Sorry for the demo. I'll tweet these slides.